Hello everyone. Today I wanted to make this quick presentation about Advent of Code. For those of you who don't know, Advent of Code is a programming competition, a contest that takes place in December every year. And it is sort of an advent calendar for programmers. And so every day you get a puzzle. In instead of a small gift, like in the advent calendar, you get a small puzzle and you can solve you can solve the puzzle. Usually there are two parts. The puzzles are made of two parts. First part is quite easy. Second part is a little bit harder, sometimes significantly harder than the first part. And if you complete all the 25 problems, you complete the challenge. Adult Code is really famous right now. Many programmers actually like this challenge because it is a combination of problem solving, really fun puzzles, really well-designed puzzles, and just a great way to keep, get in touch with the community and to do something really fun during the Christmas period. So this video is about what I learned this year, and actually also last year, because this is my second year of participating in a challenge, and I solved many problems. This year I solved all of the 25 problems. Last year I solved most of the problems, and I'm definitely not the guy that solved all of the puzzles from 2015 up to now, but I solved quite a bit of problems, and I think that I can give some valuable tips and just look back and just see what I learned this year. So this is just stuff that came out of my mind from scratch. So there's not a specific order of things. We will just follow the slides and just look at the tips one by one. So first thing first, the main purpose of the challenge is to have fun. So you shouldn't lose too much time, or not really too much time, but just you don't have to tilt and it doesn't have to be something frustrating. It has to be fun. It has to be something that you do to sort of detach from work, and something that you do because you enjoy doing it. So this is the first thing. If you see that it's something that is frustrating to you, then just drop it. Maybe you can just do it maybe on later years, or you can come back to it in um, when you will have maybe more free time. Another thing that I found very fun and very helpful was staying in touch with the community. So Advent of Code has this huge community on Reddit, and it is very fun because people post not only solutions and tips, which are very useful sometimes if you get stuck, but they also post memes and other very fun things, and it's definitely worth the effort to check out the subreddit of Advent of Code. So let's start with the actual tips on problem solving and on like more technical tips. The first thing that I would like to point out is always think of easy solutions first. Many of these problems, also the most complicated ones, at least the ones that look more complicated, they sometimes have really easy and elegant solutions. And I want to check this problem, which is day 5 of this year, which was which is a great example. In this problem, basically, you're given you were given. Let's just look at the problem really quickly. You were given a series of rules, basically, and you had to check whether the rules were valid. For example, this rule here is valid if, for example, 75 appears before 47 in this list here, and 75 has to appear before 61 in this rule here, these rules here, and so on and so forth. And the first part was just about checking if one of the sequences was valid. and this was actually very easy. You just go through the rules and that's it. The second part though was a little bit harder because you actually had to check whether um, like you had to pick, incorrectly ordered updates, so incorrectly ordered sequences, and put them in order according to the rules that you have. And the first thing that like how I solved it was in a more complicated way than what actually worked better. I solved it using topological sort, which is an algorithm that basically sorts a directed acyclic graph in a sort of topological way. So you can look at the nodes from left to right and sort of go through the graph without going backwards. But actually, this was not the simpler way to solve it. The simpler way to solve this problem was to just swap things and just swap them and check if they were valid. And as soon as they were valid, you just output that the sequence was valid. And this was so much faster and so much easier. Obviously, I'm not saying that this was the coolest way to solve it or the right way to solve it. Obviously, topological sort is very interesting. It's a very interesting algorithm and something that you maybe should learn. But this is just a quick example to say sometimes you don't have to do crazy things, or maybe if you are stuck, just think, sit back for a second and think about an easier solution. Then another thing that I think it's useful to remember is Google is your friend if you don't remember stuff. So sometimes, if you encounter a problem and, you sort of feel like you've already seen the thing, or maybe that there's something, a quote that I always like about programming is like programming is half remembering stuff and Googling the rest. So, for example, in this problem, it was day 12, and basically in part 2, you had to check for every connected components, for every connected component of the grid, for example, of these A's, all of these B's, and all of these C's, etc. You had to count how many sides this sort of polygon had. And this was kind of like I solved it with a very, very complicated and artificial solution using a BFS on small dots that I placed around the corner, around the edges, and it was super hard for me, and I spent a lot of time on this. But the simpler way was to just check on Google for a second how many sides does a polygon have, and you quickly realize that a polygon has a number of sides which is the same as the number of its vertices or vertex. I don't know if there's a plural for vertex. Whatever, you just count the vertex and vertices. That's it, and you just know how many sides the polygon has. So you just quickly do this thing, and it is a sort of easy problem in computational geometry, and you just solve it. But at first I didn't remember it, and I sort of realized it after I solved it. And so this is to remind us that sometimes just Googling very fast something, sometimes it just saves us a lot of time. Next tip is read well the problem statement. This is a day where you had this grid, this path basically, and you had sort of agents going through this path, this maze, and they sort of had to race to reach the end before the others. And the weird thing was that these agents, I think they were reindeers, they could teleport. They had the possibility to teleport from one side of the wall to the other side. I think like once every race or something like that. And you had to simulate this thing. And at first, like for the first probably 2 hours, I didn't realize that the problem statement specifically said that there was only one possible path that the reindeers would follow. So there was just um, this one path, this one available path. And actually, I was writing a solution where I didn't have this information. And this took me like a lot of time, and I ended up writing a general solution that worked also for the case where there wasn't just one available path, but it was terribly slow and very inefficient. And like after 2 hours, I reread the problem statement and I realized this thing, and it took me like 5 minutes to solve the problem. So this is to remind us that always reading the problem statement, reading well the problem statement is a very, very important thing. Next thing is sometimes it's all about giving the right answer. So we don't like we are solving puzzles, yeah, but the website and also the designer of the puzzles want us to submit the right answer. It doesn't want us like he doesn't want to us to write a perfect solution or a super efficient solution. Um, the only thing that matters is the thing that you submit to the website. And day 24 was a very very cool example of this because in day 24 we were given this huge um, basically graph of dependencies between operations that we had to analyze. I'm talking about part two for those of you who saw this. And basically we had to sort of find the wrongly connected nodes in this huge dependency tree, and to sort of fix the circuit. And the circuit was, at the end of the day, it was an adder of two numbers that took in input the digits and spitted out in output the result of the sum of the two numbers. And basically we were given this huge circuit where some gates were like switched, and we had to find the ones that were switched to sort of wire them together again, like in the right way, and to solve the problem. And actually, I found out that the quickest way to do this was to actually print the whole tree, so the whole input, and actually look at every single connection, like looking at it by just looking at it, like no code. You just print with graph feeds or whatever you want the dependency tree, and you just find the things that weren't working. And I'm gonna show this because it's very fun. And the dependency tree was something like this, and I ended up looking at it by hand, let's say, and I think it was this one. Yes, and as you can see, this thing took me like 30 minutes, but at the end of the day, I solved it in a much faster way than other people. And as you can see here, I was sort of checking the right gates, and once I saw something that was suspicious, I just underlined, highlighted it and just submitted the answer at the end. And then this is my last tip. Sometimes problems are just hard. For those of you who competed this year, you will probably recognize these numpads. This was day 21. It was a very, very interesting yet very, very hard dynamic programming problem. And this problem was just hard. Like it wasn't very easy. It wasn't very intuitive, and it definitely required you to maybe take out a piece of paper and sort of think on this for quite a while. And maybe on the 21st of December, people don't have much time. Me either. Um, I was probably out. I think I was in it was during my holidays, so I didn't really have much time to solve this problem. But I ended up going back on it like on the 26th or 27th of December. and then I had enough time to solve it, and I just solved it. So sometimes problems are just hard. If you don't have time, it's fine to go back on problems on later days, and just take allocate the proper amount of time on some hard problems. Um, yes, for those of you who don't know, D21 was about finding the correct, the minimum number of moves required by a chain of robots to move, to sort of digit a code on the numeric keypad. But basically, you had to control a whole chain of robots that control these directional keypads. It was just a mess, and it required me like a couple of hours to solve, like maybe a couple of hours of thinking and then like 1 hour to implement or something like that. So it was definitely a hard one. Okay, so that's it for today. This wasn't a very long video. If you like this video, comment out, and maybe um, I will check out the comments. And I think I will also post a video on Everybody Codes, which is another challenge that took place this year for the first time. And I think it was very interesting. It had some very interesting problems. And I think I'm going to post a similar video for that challenge as well. So see you, everybody.